Hello everyone, welcome to the Django tutorial series. In this tutorial step, we are going to set up a VPC in AWS and securely launch an RDS instance in a private subnet. Before moving forward, let me give you a brief explanation on what is AWS VPC and RDS. Amazon Virtual Private Cloud, Amazon VPC, is a service that lets you launch AWS resources in a logically isolated virtual network that you define. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. If you're working with AWS VPC, you need to have a basic knowledge of networking. Don't worry if you don't have those skills. AWS has uploaded a video on YouTube explaining networking fundamentals. Go and watch that. I will make sure to provide the link in the description. Let's move to RDS. Amazon RDS, also known as Relational Database Service, is a distributed relational database service provided by Amazon Web Services. It is a web service running in the cloud designed to simplify the setup, operation, and scaling of a relational database for use in applications. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. As of today, the currently supported database engines are MySQL, Oracle, Postgres, SQL Server, MariaDB, and Amazon Aurora. Let's get our hands dirty. As you can see on my screen, I'm already logged into my AWS Management Console. I'm going to search for VPC and navigate towards the VPC Management Console. Click on Your VPCs. As you can see, AWS already provides a default VPC. Now click on Create VPC. I'm going to name it as Django VPC, and the seeder block will be 10.0.0.0/26, which is going to create 64 IP addresses. Seeder, which stands for Classless Inter-Domain Routing, is an IP addressing scheme that improves the allocation of IP addresses. To know more about Seeder, please visit the link shown on your screen. After filling in the information, I will click on Create VPC. As you can see, the VPC has been successfully created. Now I'm going to click on Subnets. Under Django VPC, I'm going to create 4 subnets with 2 private and 2 public subnets. I will divide the subnet into 4 blocks with 16 IP addresses each. As you can see on my screen, I've created 2 private subnets in different availability zones. I will follow the same approach for the public subnets. We have successfully created the subnets. As you can see on my screen, the available IPv4 addresses is only 11, but what about the remaining 5? The remaining 5 are reserved by AWS. Amazon reserves the first 4 IP addresses and the last 1 IP address of every subnet for IP networking purposes. To know more about this, please visit the link shown on the screen. Next, we are going to create a route table. A route table contains a set of rules called routes that are used to determine where network traffic from your subnet or gateway is directed. There will be 2 route tables, one private and one public, under our Django VPC, and we will be associating our subnets into the route tables. Next, we are going to create internet-bound traffic to our public subnet. For that, we need to create an internet gateway. I'm going to create an internet gateway and name it as Django IGW. And attach it to our Django VPC. I will now add a route which directs internet-bound traffic to the internet gateway. Maybe your application is running under a private subnet and you want to update or patch your application. You might need the internet, but you don't want your application to be exposed to the outside. For this, you can create a NAT gateway. NAT, network address translation, gateways enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating a connection with those instances. Let's now move to RDS Management Console and spin up our first RDS instance. Okay, we've now arrived in the RDS console, but before starting up, we need to create a subnet group. An RDS subnet group is a collection of subnets that you can use to designate your RDS database instance into a VPC. Your VPC must have at least 2 subnets. These subnets must be in 2 different availability zones in the AWS region where you want to deploy your DB instance. I'm going to click on Create DB Subnet Group. I will give it a name, Postgres Django Private Subnet Group. It's a long name, but you can provide a short name. Make sure it's between 1 and 255 characters. Next, I will choose Django VPC as my VPC identifier. I will choose 2 different availability zones under which I will be selecting my private subnets. And finally, I click on Create. Now I will move forward, creating our new database instance. I will choose the database creation method as standard create. As you can see, AWS provides a lot of database engines. For this tutorial, I will be using PostgreSQL. If you are interested, you can also use Amazon Aurora, which has been developed in-house by Amazon. Aurora is a MySQL and PostgreSQL compatible relational database, which provides high performance throughput, 5 times faster to standard MySQL and 3 times faster than standard PostgreSQL. Next, I will choose the 10.5 version. I would recommend choosing a version which is compatible with your application. Under Templates, make sure you choose Free Tier if you are interested in saving some money while experimenting with RDS. Now I will be providing generic settings like DB identifier, username, and password. For this tutorial, I will be choosing T2.micro instance class, which provides 1 GB of RAM, which is quite okay for our application. I will disable storage autoscaling as we don't require it. Based on your needs, you can use it for your production workloads. Make sure to choose Django VPC in the connectivity section. You can see it automatically populated the DB subnet group, which we created earlier. The public access should be no, because we don't want to assign any public IP addresses to our DB instance. Only the EC2 instance can connect with the RDS. Now I'm going to create a security group called Postgres-Django-SG. Security group is a virtual firewall which works at an instance level. We also have Network ACL, which stands for Network Access Control List, ACL, an optional layer of security for your VPC that acts as a firewall at the subnet level. The security group will be created in the AP-South-1A availability zone. We will also be creating our EC2 instance in the same availability zone, which I'll cover in the next video. The database port 5432 will be the default, and we're not going to change that. Make sure under database authentication, you select password authentication. For more stringent security, you could also go forward with IAM authentication or Kerberos. Now under additional configuration, I will provide the database name. I will name it as my_Django_DB. We will be using the default DB parameter group. There are no changes in that. A DB parameter group stores DB engine configuration values that are applied to one or more DB instances. Now I will click on the Create Database. It will take a few minutes to launch the DB instance. I would like to highlight a few things which I didn't cover in additional configuration, like backups, monitoring, and maintenance window. It depends on the use case of what you're trying to build. These tools are very essential when you're working with a production database, but if you're using RDS for the first time, just like trying it out, then it's not necessary to use those features. Okay, our RDS instance is now up and running, as you can see with the status showing as available. Let's move to the next tutorial step, where I will be setting up an Ubuntu desktop in Amazon EC2.